Since then, I've gone off and worked in a few different energy efficiency programs, and most recently, a couple of years ago, joined Electrify My Home. Marco. Hey, Marco, what's going on? I see your little globe up there. And so this is what we're doing there. We're trying to install the most efficient and cost-effective electrification solutions for residential homeowners primarily. Focus on taking care of the electrical panel and putting each of our customers on a path towards full electrification over time, but planning out their future and taking some important design steps at the beginning to avoid potentially very expensive and aggravating consequences down the road. And then we also have a training program to teach other contractors how to do what we're doing. Okay, so I'll skip over that. We have several training programs throughout the state that we've been working on kind of on the side. So in our day jobs, we're actually installing systems in residential homes. In hours, 45 to 60 of the week, we work on these training programs. Okay. So the importance of the panel, a really quick analogy that I'll just flash forward since we were just talking about it. Heat pumps are the heart of the system when we talk about a residential house. So we need to make sure that we're prescribing the right heat pumps for the right applications. We're doing load calculations. We're sizing the ductwork correctly. We ensure that the right amount of airflow gets into each room, that sort of thing. And then on the electrical side, the panel is sort of the brains of the system. So we want to make sure we're not filling our brains with garbage, right? In this case, the panel with garbage, right? We're not installing a system that's going to take up half of the breaker slots that are available and leave no room for future electrification. Okay, so the question that we were just leaving off at was, are these panels full? So it's a bit of a trick question, right? If you take a look at the actual panel and you can see there really aren't available physical slots to add more breakers in either of these panels. So yeah, it kind of is full, right? But having a full panel doesn't mean that there's no available capacity in that panel, right? And so, here's a really quick breakdown. I'm not good at math. I'm not an engineer. I just, kind of pretended to fit in here for a couple of years. 100 amp panel gives us 24,000 watts through a really simple equation, right? Amps times volts. 200 amp panel, we get double that. So that's the potential capacity at max in panels. Okay, so there's a couple of studies that have been done just looking at several thousand homes and what the current panels or what the current max capacity looks like in those systems. So on the y-axis here, we see count of homes at certain max power levels, and then the max amperage on the bottom here. And so the main takeaway, and usually when it comes to panel sizing, if you're not familiar, usually we either have a 60 amp panel capacity, which is mainly for really, really old homes and apartment complexes. 100 amps, which is very typical in homes built before, 1970 or so. And then 150 or 200, 200 being kind of the standard today. And so what we're seeing is that, this company HEA that has a really great tool called PG&E Home Intel. So if you're a PG&E customer, you can actually go onto their site and answer a whole bunch of questions for free, and it does a kind of a virtual analysis using your smart meter data. So really great service. So they looked at 22,000 homes that have kind of opted into their service, and they wanted to see what's the max amperage that was drawn during that period of time. And so the takeaway here is that 98% of those 22,000 homes have peak power below 88 amps, right? And so a big part of the discussion in electrification from policy circles and program design is, everyone's going to have to update their panels or upgrade their panels at some point, so we should pour a bunch of money into that. So there is a time and place for that, but the data is telling us that we have lots of capacity available.
I have a question.
Yes.
That's just an average number, 98%. I mean, when you go out to certain areas where there are mega mansions,
Yeah.
they have a car charging, the
Right.
heat tub, and you're gonna,
Yeah, that's this guy over here.
yeah.
But those are probably 200 amp homes also.
No, I know that. It's not about,
Yeah.
it's just more than the 88 amps that's an average of all the homes here.
Yep,
So
good
we have
point.
a 1972 home, that just doesn't draw that much.
Oh, yeah, absolutely. So at the end of the day, we need to take a peek at each home. But on a massive scale, when we're talking about all the millions of homes in California, right? The massive number is what the data is showing. But yeah, very good point. We can't just take this and run into every house and say, oh, no, you're fine. You'll be good. You have plenty of capacity, right? We still need to meet NBC load calculations. So you might look at this and say, okay, well, that's great, but none of these customers have electrified yet, right? We're still early on our electrification journey in California, right? So that's why they're so far below 100 amps here. And so SMUD put together this cool chart. And the green chart, the green line here is just overlaying what we just looked at in the previous picture. The blue line is showing the number of mixed fuel SMUD customers, which is on the left y-axis. So those are folks who have gas and electric still. And over here are all electric homes. And so instead of amped, we're looking at peak kW, but essentially the same thing, right? So 24 kW would put us right over here. So a similar takeaway, even homes that are all electric in SMUD territory, that orange line, there's certainly an increase in the max kW or amperage pulled throughout the year, but it's only maybe 3 or so kilowatts. We're still pretty good from a total utilization aspect with respect to whether or not we need to upgrade most of the panels that are out there to get fully electric.
What's the green line?
The green line is the overlay from the previous screen. So it's taking this curve and just placing it on this graph for kind of comparison purposes. Because we have two data sets. We have the one from SMUD, which is blue and orange. And then the green one is from the 22,000 homes from the HEA Pacific Gas and Electric study. Okay, and then here's a fully electrified house here in Davis. It's actually my house. I plotted my 15-minute usage across the course of the year. Really, it took about 5 minutes to do this. Really easy to do if you have the smart meter data. And I took a peek at the max full. It's about 6.5. I'm maybe not your average consumer, but I have a heat pump water heater, a 2-ton heat pump for the house, an induction cooktop, and electric resistance dryer. And again, by comparison, sort of the magic number for 100 amps is 24. So again, are these panels full? Yes, they're full on, and there's no remaining space, but they're not full on available capacity. Okay, so now we have plenty of capacity available, but it doesn't meet the cover, right? And that's what things usually come down to with respect to pushing towards a panel upgrade. So all practitioners out there, electricians, HVAC companies, anyone installing a new circuit, a panel for a new electrification opportunity has to follow the National Electric Code. In all honesty, and in the real world, very few people actually know how to do full load calcs, even though it's extremely easy to do. But most of the time it's like, oh, look, there's a free breaker spot. I'm just going to stick something in it. But that's kind of a separate issue. There are rules in place, and the National Electric Code is focused on safety, right? So we don't want to be pulling too much current through the wires. So the rules and requirements for load calculations are in place to prevent overheating of the wires and the bus bars, right? We want to avoid any issues for shock hazards and fire potential in the house. And so because of that, we can't just take the total large remaining capacity that's available from some of those previous charts. We have to follow the right rules and procedures. So for a proper load calculation, we have two main options. And one of these no one ever really talks about. I've never had to use it before, but there's a top-down method. So the way the top-down method works is that you can look at a customer's previous 12 months of smart meter data and look at, I think it's either an hour-long, the highest hour-long watt draw during that previous 12 months. So you take that and multiply it by 1.25, and then you add the full nameplate rating of all the new proposed appliances on top of that to prove that you're not going to exceed the current panel capacity you have. If that makes sense, right? So this is kind of a quick and dirty method. If you only need to add one circuit, this is might be a good way to go about it. But if you want to electrify a whole house all at once, usually the bottom up method is the way to go, and this is the standard. This is a traditional electrical load calculation. So for this, I have a, I'll show it on the next slide, but we take the nameplate loads throughout the house and we multiply that by different demand factors, and those are called coincidence factors, because it's almost unforeseen for you to flip on everything in your house all at the same time, right? It just never happens, right? So lights are off, TV's on or off. We're always kind of turning things on and off. So the code allows us to get kind of a discount on some things, but not others. Okay. Let me see how we're doing on time. So is it okay if I go over the 30-minute kind of threshold? Yeah, okay, cool. Just stop me if I'm going on for too long. So here's an example of an electrical load calculation, a very simplified version. So I like this one. It's gonna be tough for people in the audience to see this, but step one is we take the square footage of the house and we multiply it by 3 watts per square foot. So this is the first thing we have to do for the code. And that's to kind of get a general breakdown of the different plugs and outlets and light throughout the house. Next, we have to count the number of kitchen circuits and 1 circuit for laundry, at least. Okay, so we count up all those, and you can't see it here, but it's adding all those up, the wattage in the table here. Next, we move on to our appliance loads. So if it's a built-in microwave, dishwasher, essentially the big appliances that are in a house, we have to count most of those. So garbage disposal, a dishwasher, a stove hood vent if it's hardwired. So we count up the nameplate amperage and voltage for those appliances, stick it in the table. Okay, so then, and also our induction range, our dryer here, in this case, it's a heat pump dryer. In this case, it's a heat pump water heater. We count up all of those loads. It comes out to 32,730 watts. It's a heck of a lot more than the 24,100 amp threshold we were talking about before, right? But the code allows us to, we take the first 8,000 of that, and we count that as 100% coincident. The remaining, you take the remainder and we can multiply it by 40%, again, because we're not using everything all the time. And that comes out now to about 17,800. Okay, so then we move on to the next section. And this section includes all of the loads that the code says we have to put as 100% coincident. In other words, we just have to assume they're always on, because they're usually higher utilized loads that have the potential to run longer cycles. Okay, and because of that, again, it all comes a bit down to trying to avoid heating up the wires and bus bars and causing fires, right? So your induction range, I don't know, in some houses, they might treat it like a commercial kitchen or something. People do this, right? Maybe that should be down here for that house, but otherwise you're using your, stove only a couple times a day. Okay, anyway, skipping to the end here, we take the total from here and the total from here, add them together. In this case, you can't see it, or I can't see it, but it comes out to 97 amps. So this house is just right under that 100 amp threshold, but it's fully electrified. So
But your car charger, you don't have in there.
0 amps. So let's see. Yeah, good point. So this one is with circuit pausing. So I'll go into more detail when we get on the circuit pausing slide, but what's happening here is we have 2 CTs that are hooked up to a device that is hooked up to the EV charger. And those CTs are sensing current flow through the main wires on the house. And so it's not going to allow the vehicle charger to operate if the panel is above 80% of its capacity. So that's a trick one of the tricks we can use to keep the house under 100 amps. But yeah, good, thanks for pointing that out. Okay, I'm gonna blast through this. I think it's kind of general knowledge now that getting a panel upgrade is quite difficult in some situations. And if you're not convinced of that, just ask Teresa.
I did do it though.
You got
Yeah,
it
What do they cost, Teresa?
10 grand, but almost my marriage.
done. Okay, for the people on the phone,
Costs
there was a question about how much, I guess we have microphones. Okay, so, panel upgrade costs, 3,000 to 8,500. It kind of all depends on what the scenario is. If we need to trench, right, there are several areas in Davis here where, we don't have overhead wiring from from the utility pole to the customer's house. Instead, it goes underground under a bunch of concrete. You have to trench and add additional infrastructure. If the upgrade for your house to 200 amps is flagging a transformer upgrade for the utility, we're in a whole new ballgame with respect to costs, timelines, and complexity, right? So
Yeah,
anyway,
we did get a quote for 50,000 in during West Davis because the transformers maxed out.
Yeah.
And everything, so
incredible.
we can't do it.
Right, so you're you're forced to either pay 50K or come up with some other solutions. And it's gonna be very hard to electrify everything out there, right? So, the hashtag electrify everything, it's very complicated, hard to do. But, we all wanna try to get there at some point for certain applications. Okay, this is just to say it gets really so there are rules for PG&E and the other utilities. For PG&E, it's covered in what they call the green book of basically what you need to go through to upgrade a panel when it's right above a gas meter. There are rules in place that prohibit you from doing that without going through sort of the long process. So what we like to do is just electrify the whole house and then get rid of the meter, and then it becomes a little piece. That, we can't always do that. Okay, so utility infrastructure, all the red stuff is what the customer owns and is responsible for, right? The meter, the weather head, which is the thing that pops up and feeds the meter from the utility. And then the transformer, the pole, kind of everything in between is the utility's responsibility. To maintain and ensure that it's going to meet the max capacity requirements of the sum of all of the panels in that neighborhood. Here are just an example of some of the steps that are involved. So if you want to put in an application for a service upgrade to 200 amps, for example, there's a planning phase, application phase. So they actually are really good about getting back to folks within 3 days with a very preliminary determination. And that's just, yeah, we've got no issues in your area, like everything should be straightforward. Go ahead and, move forward.
Is that PG&E that's making that determination?
Yes. Yeah. So yeah, I should say this is kind of from PG&E perspective. The other utility might be a little different. And then, if we don't get through that quick assessment, it kind of escalates. And it kind of keeps escalating based on what they find and the layers that get peeled back along the way, right? So in your circumstance, did it take a little while to figure out that it was going to be 50K?
No, it took me less than a week.
Yeah,
They
so,
sent me the map where the transformer is, everybody hooked up. So we're in townhouses, so every two townhouses connected by 200 amp.
right.
So it splits it and everything's underground and the whole line is backed out.
Yeah,
That's why,
got it.
so you need new wiring, new
Yeah.
transformer.
Yeah, so someone else in your neighborhood probably already went through that, and like, oh yeah, this whole neighborhood's screwed.
I didn't have this problem in terms of there was plenty of capacity on the transformer, but I'm a little confused about, I did a bunch of digging into all of the CPUC rulings. And it really seems like other than the local wiring, other than the wiring from the closest service drop to your property, everything I'm reading says the costs of the transformer upgrades are to be borne by the ratepayers, meaning PG&E
Everybody.
itself. So I'm not sure that they're doing the right thing and saying that like you're somehow on the hook for that transformer upgrade.
Yeah, I just wanted to do it to see what they charge. For me, it's not an issue because I'll put in a smart panel and then it's solved.
But you might go back to them and say, why am I paying for your transformer upgrade? That's not my cost.
Yeah, but even let's say we take off 20,000 or 25,000 for the transformer upgrade. You're still with the trenching and everything.
Well, if you want to entertain yourself, you might fight with them about that.
Yeah, no, I already have a solution. So it's no problem. You can get everything into the house.
Right. So anyways, if it gets more complex and you wanna keep pursuing, it takes a really long time, sometimes over a year. Right, so it's like, well, no, I wanna electrify my house today, I don't wanna do it in a year, it becomes more complex. So here are some of the solutions. So these are all things that we have done ourselves, and then before that, just, here are some of the ones we need to consider in terms of physical space. Because we need to battle against physical space as much as available capacity. Yeah. So, a heat pump, 2 to 6 spaces, and everything we do, it's 2 spaces for the most part. Yeah, well, anyways, it's all up there. So solution number 1, we're gonna go ahead, this is the same panel we looked at earlier, right? And we're gonna take this little dryer circuit. Our task is to add a heat pump water. So we want a 30 amp circuit. In this case, it's a 200 amp panel, like everything is okay, we have plenty of space. So option 1, quad it out. I make these really cool breakers called quad breakers that allow us to hit both sides of the bus bar to get 240 volts, but it just narrows everything in so we can fit 2 circuits in a smaller amount of space. So that's option 1. When we can find it, sometimes we come into certain panels that really they're much older, or we have different capacities that are just a little bit obscure, and it's hard to find breakers for those instances. The supply chain's gotten a lot better, but depending on the city, they may take issue with you putting another company's breaker and seeing the panel, for example. We gotta be careful about that. Option number 2. We're going to use a circuit splitter. So a circuit splitter, the way it works is very straightforward. We take one 240 volt circuit. We run one line out of the circuit splitter to, in this case, the dryer, and another line to the other 240 volt appliance, which is the water heater in this case. So it allows us to get a fully blown heat pump water heater in the house, even though we're limited on space and capacity. The downside is that we can't dry our clothes and heat our water at the same time. Okay, so if you're in a house and you have a bunch of kids and on Sunday kids, or you like to take a lot of showers or whatever it is, different scenarios, it'll be tough to run your laundry all day and then come back at the end of the day to take your shower and have a fully hot shower. But for certain homes and lifestyles, this makes sense, and for certain applications. A really great application is EV charging. And what we like to do is run one of these, a simple switch, and because it can carry a 40 or 50 amp load, we'll run one to the EV charger and one to the range or cooktop, because we're rarely needing to charge our car and cook our food at the same time.
If you have a circuit splitter, does that count as just half of that load in your load calc, or even if you have a bunch of other hardwired stuff in, can we say, well, there's only one circuit it's attached to, so.
Yeah, the code is still catching up, but we haven't found an instance yet where we haven't been able to say there's only one circuit in this house, essentially.
Okay.
So that's been able to hold up just fine. All the one-on-one city inspections we've had. So yeah, only have to count one of the appliances.
Where does that go on your sheet? Does that go on the kind of like the continuous load sheet, that section?
Yeah, usually I just put a 0 for that appliance in, like in the quantity, for example, and so the amperage is going to show 0, and then I put a note in saying that it's on a circuit splitter, and I attach the spec sheet. And ultimately, like, I don't know, half the time it leads to questions, half the time it just gets pushed in. But more and more of these are getting out there in the real world, right? So more building departments, inspectors, contractors, customers, we're all becoming a little bit more familiar with the technology. So this was what was in the example earlier, is a circuit pausing device. So we haven't used too many of these, but they really, they work well. You can kind of ignore these arrows of the plus, it doesn't really apply in this scenario. So in this case, we have these two little CTs that are reading the current through the main wires coming through to the main service. And the simple switch in this case is just going to say, is it above 80 amps? If this is a 100 amp panel, is it above 80% of the capacity that's available on the panel in terms of what the house is currently using? If so, I'm not going to let that EV charger run or the water heater run or whatever we have hooked up to this until it drops below that capacity. So, another thing that we don't have to count on that NEC load calculation. Another really straightforward option if we're limited on physical space, but we have plenty of space in the panel, just add a sub panel. So we can add a sub here and move some of these circuits over to the sub panel. Right, just to free up a little bit more space. And so sometimes this is a great option. Like let's say they wanted to add a hot tub. Well, we've solved their issue for getting the water heater on there by putting in a quad breaker. But when it goes time to put their hot tub in, here we have luck, right? And they have to pay a bunch of money to get that done. Right, so kind of long-term thinking and planning is really important in this phase. And trying to get a box swapping HVAC company or a plumbing company that only does water heaters to think comprehensively is exceptionally challenging because there's really nothing in it for them other than customer satisfaction. So that's one of the things that we're trying to change. Wish us luck. Okay. Smart panels. So these are really cool. We haven't installed any of these yet. This is a kind of a dumb panel with smart breakers in it.
Yep.
And then this is a smart panel with dumb breakers in it. Okay, so the way a smart breaker works is, it ties in, you can control it from your phone, you can set rules of, when it's on and off, that sort of thing. You can do all that in the span panel, it's just the brains is in the panel itself. And so the great thing about this is you can keep your 100 amp service and you can tell this span panel, I don't want my panel ever to exceed 100 amps. So make sure that never happens for me. And if it does, and we're creeping up, turn off this circuit first, this circuit second, this circuit third, and this circuit fourth. And it can also operate as a critical loads panel for a battery. So you can do the same thing for that. When the power goes out, you can say, I want to keep this circuit on, but not the others. So really cool piece of technology, also really expensive, but it solved a really important issue. Okay, and then, when we talk about trying to keep some of the existing 100 amp service panels or less and kind of tricking the system into allowing us to meet the load calc, we still need to keep in mind safety through all of this, right? If we walk in and we see a panel that's just garbage, we see evidence of maybe, burning or, bus bars, melted or something, we have to take care of that and fix it, right? And so these are examples of some really older style panels that are being phased out over time. So usually a good idea to think about swapping these out if they're in bad condition.
And FPE is Federal Pacific, was that?
Yes. I don't know what IT is. I've only heard them described as numismatic, and they're very rare. Okay.
Wait, Peter's got.
Yeah, I share the flow, so maybe you address this. Going back to the panels, have you worked with solid state breakers yet before?
No, I don't think so.
Yeah, so there's there's all circuit breakers like the mechanical, right?
Mhm.
But there's solid state breakers. It's a company called Atom. So it's basically like circuit functions circuit breaker. So you have better control, and you can also set the max amperage. It's variable, right?
Oh,
So
cool.
when you install 40, you can only ever do 40. When you install a solid state, it could max out at 20, it could be 80, it could be 100 if you want, right?
I wonder if these are solid state breakers.
No, those won't be solid
These
state.
just-
Those will be mechanical, right? I think Schneider maybe Siemens has the only smart breakers.
Yeah.
But they're freaking huge and they're still mechanical.
Got it.
Right, but Atom I think they're doing, you can individually control every circuit.
Okay.
I don't know how
Maybe.
expensive they are, but I know
Yeah.
that they're like
On the
EV
horizon.
solutions, right? So for like a apartment building.
Yeah.
Instead of having to do that, you can just do a whole bunch of solid states and you can.
Yeah, absolutely. I mean, at the beginning, we were talking about really how much capacity is available on panels and how we almost never reach that capacity. So to the extent that we can use smart technologies to deliver what we need for full electrification without sacrificing comfort or lifestyle, these are the kind of solutions we need to pull on that off. So,
Before you jump to
It's
the
great to
diet,
see.
I have another question about the splits.
Yeah.
You said that the EVs are probably the best option, but most of the EVSCs and the cars doesn't like to restart after power off.
okay,
So they throw an error. If the power went off, power come back and the car is already plugged into the EVSC.
Yeah.
It's not start charging again.
oh, really? Yeah, I don't know, we maybe have 5 or 10 of them out there. I haven't had the feedback yet, but.
The way to
one we
do
put
it
them-
is to program it to start later, so it doesn't, but
Yeah.
it need to be programmed to start. It will not start by itself after power is coming back.
Got it. So we don't want to interrupt a active charging cycle, whenever possible.
Yeah. And I hope that many of them start to kind of think about it, and do their own ones,
Yeah,
but
yeah,
every charger we have here, if you just go and turn the power off and on again,
yeah.
it will not charge again.
And like on the breaker, on the
Yeah.
box.
Yeah. If you
And
just
the
turn,
way this one works, it still provides a very small amount of
Yeah,
power.
you trigger
That's
it,
the way.
and then- Yeah.
that's the way to keep it alive.
So, right, to your heat pump water heater, for example, the same thing on those, right, is that if you turn them off, they're gonna run through a really long startup cycle. And so it provides just enough to keep the control board up and running. So maybe that's how they've gotten around.
Typically.
That will
you
be
take a look.
interesting how the AVSC knows what to do with that.
Well, I wonder how that works on the getting code compliance there.
Yeah.
The
I just know
demonstrate.
my
That's an interesting.
daughter put in a span panel, we put their EV charger, and that is a charger ramp up and down under load.
Right, yeah, the spin and drop.
Yeah.
those are the-
When you go to a permitting official.
Yeah.
And run it through, what, are you just saying, take a look at 625, or are there other ones you pointed? If you're trying to like, because there's a specific one for load management, you can say, is this done, right? Or is it more?
It all depends on who you're talking to and what they believe in and how much free time they have. It really just, what argument they had with their partner that morning. So, yeah,
What they
most of the
believe
time, what we do is we take the manufacturer spec sheet
Yeah.
and anything they've published about being able to do what it's claimed to do, pass that along with our permit package, and we never hear back. When it does come up, we show that it's UL listed, and just we keep kind of providing more information as needed to get things closed down. We haven't had one yet that we haven't been able to work through.
It's funny.
It
They don't
just-
believe in the NEC code after like the 1995 version.
Like, I don't believe in the estimate.
Yeah, it just all depends. I really wish the requirements were, a bit more seamless across the different entities we work in. 60 different cities potentially, and have to have all these conversations. Or whatever. This guy, if you don't know of him, you should check him out. His name's Tom Gavitt. He came up with this thing called the Watt Diet. So I only have one of his slides, but he's a friend of our company. And what the Watt Diet is it's, prescribing the most efficient, power efficient appliance options to enable us to get further with electrification under the smallest panel possible, right? Now, some of these have impacts on, comfort and expectation and lifestyle that we need to discuss with our customers to make sure they're aware of this. But, and I apologize, it's kind of a confusing chart, but down here is the counted panel watts, right? And then we have all these different options throughout. So up here on these items for cooking and clothes drying, it applies the 40% factor we were talking about before. And all these down here, it provides it applies a 100% factor. And what Tom's getting at in this chart is that when it comes to picking on a dryer for that home, you know, if we're electrifying everything, moving from gas to electric, we can pick a resistance dryer that comes right up against 8 amps, or we can provide one that has, you know, 1 amp. And then, you know, they've got combined heat pump washer dryers now that can do both jobs in 2 hours, which is pretty cool. And save 8 amps. On cooking, these aren't really out yet. Our company, so there's a company called Channing Street Copper, and I think there's one others, and they provide a plug-in induction range. They can just plug into a 120-volt outlet in the house, and it uses a battery to make up the difference that you would otherwise need through a 240-volt circuit. These are super cool, still pretty early days. We got to install the first 3 off of their new assembly line, so that was pretty exciting. I don't think we're gonna get into the range install business, but nonetheless. If we install one of those, we could save 16 amps, right? And the customer gets a backup battery in their house that they can use to plug their fridge in. Sorry,
Yeah.
do
I was
you-
gonna ask, what's the difference in costs between that?
Yes.
That's probably gonna be about $6,000. The cheapest induction range you can get now is, I don't know, $900, $1,000.
Wow.
And then most of the induction ranges out there are probably in the $2,000 to $3,000 range. But you get a 30% tax credit on it because it has a big enough battery. That helps a little bit. And you get a small backup.
What was the brand of that? What did you say it was called?
Channing Street Copper. And they're out in Berkeley. Yeah, you should go. Kelly, you should go have lunch.
Are you gonna bid the battery into the wholesale market for DR? For demand response? That's a joke, that's
we're
not a real thing.
Actually,
Yeah, you could, but it's
they
like,
are,
We won't be, but they will.
yeah, they will.
And Impulse, another supplier of the batteries, of those induction stovetops is called Impulse.
Oh, yeah.
And they, they're trying to push service and features that once you have a battery there, you can heat a quart of water in 30 seconds or something like that. Because you can draw upon the battery for a very high power heating that you could never even do with a 220 system.
Yeah.
And it's sort of surprising to see how a feature out of it, the adversity.
Yeah. Forgetting the acronym, but they're calling them ESA appliances now. So that's the start. They're working on a plug-in heat pump water heater battery too. Really the opportunities around this. So really excited to see where that goes. So anyways, it's still early days, but we could save 16 here. Water heater, install 120-volt heat pump water heater. You know, but again, those don't fit everywhere. They run really long cycles. They make noise. You have to think about all these things. But you know, let's say we put in a really big one that's going to use 6 amps less. Anyways, you get the point. We can make all these decisions. This is probably Tom's favorite. He talks about how we really oversize our EV chargers because we.
But he made a mistake under the regular 120-volt plug on EV charging. Because in an electric car, when you charge, you have a base load that runs the cooling and everything. And it draws more power at 110. So less power into the charging than 240. So I don't think the first and the second bar are correct. I would almost say they should be even.
Yeah, I think he's just like taking the nameplates, multiplying them together, but we should monitor some of those and see the direction.
Yeah, because there's a certain power the car needs to do all that stuff.
Yeah.
The housekeeping.
So, okay, let's cross that one out. His point is we could put a different size breaker in, set the dip switch settings accordingly and whatnot to better match the number of miles or, your actual transportation activity lifestyle. So in a lot of cases, depending on how much driving you're doing, a 20 or 30 amp might get you by just fine. You really need that 60 amp power charger in your house. Maybe you do. I don't know. Maybe you're like commuting to San Diego back.
This is 240, 10, that's 8 hours? 2 hours. Is this an 8 hour plug-in time? That's 240, 10, 24.
Yeah, you probably included the assumption of what it would take to get you going.
Okay, so that might be like, yeah, it might be like 8 hours.
So anyways, we can play this fun game called the What Night and get customers utilization down far enough with their appliances if we select them carefully to kind of keep things in control. So anyhow, I know I'm at like 51 minutes, but I'll just keep rolling. Okay, these are some examples from the field. I think I've got 5 or 6 examples. Right, so these are real panels out there in the real world projects we've done. This first one here, we've got 100 amp service. Customer wanted to remodel and have full home electrification. So 100 amp panel over the gas meter. We talked about that earlier. Breakers were mislabeled. Anyways, there was a whole bunch of unexpected loads. It was kind of a mess.
We're laughing, but I think that that could be inside of my house.
Yeah.
Opened your panel? Yeah.
So this one was kind of, I don't know, this one was interesting and not something we maybe would recommend doing, but we put in a simple switch on the heat pumps. So we had 2 heat pumps on the sub panel, and then the other side went to his induction range. Now I'm gonna need you WCEC engineers to tell me why that's a bad idea to interrupt a, compressor in the middle of its cycle. Or Randy can just tell me.
These are
But
inverter or just single speed?
Inverters. But this was a temporary holdover because he was undergoing a remodel, wanted to get his heat pumps in there and done, so that he could use them for the winter time. But he was undergoing the process of a panel upgrade that was taking a while with PG&E. So we got in there and kind of put this temporary solution in place. But again, he wasn't able to use his range at the same time as the HVAC for his house. We design our systems to run very long cycles for long periods of time, so wasn't a good long-term thing, but we got it done and it held him over so that he got all the service he needed until he was able to upgrade the panel. And we just went back to switch all this out and fix it. So anyways, maybe I should have made this example like 4 or something. Okay, another one, 125 amps in Petaluma, really old house, gas furnace, gas water heater. And we ended up putting a multi-zone heat pump with wall mounts. We don't do too many of those, but it was the right choice in this decision. Water heater installation and air sealing. So really the panel we left the same, but we put in a plug-in heat pump water heater to enable us to meet the NEC load count for this scenario because you would have been over 125 amps. Yeah.
Are you, like, you're not changing the capacity of the panel, but you're putting in like a new panel? Like a new panel box, basically.
In
Or
this case, no, there was sufficient breaker space that we would just pull the breakers out of it.
And just put in the old breakers that were installed and now are like fire risk. Like,
They're far away.
I've done EV projects before, we go to those EV bonds, they have like Cisco breakers or something.
Cisco.
Yeah, 40 years ago, they're like,
Right.
you cannot use these will kill people, but like no one changes them out because you're not required to until like you do a retrofit or unless you have to do a electric, then you have, right?
Yeah, exactly. So in this case, it was still a modern panel, at least even though the house was ancient, it was still a modern panel. So we were okay in terms of safety. Okay, this is one in Davis, underground feed from the utility. We learned a lesson on this one. So the feed wire was capable of 125 amps. So we saw that and we said, like, oh wow, this wire is big enough from the utility. We can just put in a 125 amp panel. And then when we went to roll that through the process, PG&E made us aware that there was direct burial, so it wasn't conduit. And so all throughout this whole neighborhood, we're still stuck at 100 amps. So we had to figure out another way to make this work. And so anyways, they wanted to fully electrify their house. They wanted a future EV. And it was a bit of a mess. We put in a span. Okay, so this ended up working really well. And we still kept the 120 volt heat pump water heater. Probably didn't need to, but it made for a much easier installation because running the wire up through this recessed box into the attic would have been a bit challenging. So yeah, this fan ended up being a good solution on this one. Mainly because, you know, A, the 100 amp limitation, but also they wanted to add that EV charger in the future. So we wanted to make sure that we could meet that, and the garage was on like far, far other end from the house. So we ended up kind of pre-wiring that and getting the wire in place so that it's gonna be much easier to handle that down the road. So we could still, we probably could have done a circuit splitter, but. Anyways.
What's fast, what's fast to customers?
Level, I mean, they,
Well, is it level- is it like a-
they don't know the difference.
Yeah, but are they, it comes as fast, they're like, oh, I want 240 on 20, or they want a
To them,
240 on.
it means,
Yeah.
a level 2 50 amp charger
Yeah.
is usually what we're hearing.
So, yeah, because most cars today, except like some of the older Model S's, like, can only max out at full.
Yeah.
Two, so it's a 60.
Yeah. Yeah, that's- Okay, this is Larry's house, one of our companies, so it doesn't really count, but he had a Zensko, which you mentioned before, just old panel, it was in good condition, you know, there's no evidence of, you know, arcing or any burning marks or anything. So everything was still in good enough condition, but you know, it was about time to be replaced. So, similar story, 100 amps. He wanted to finish his electrification process. He had one thing left, which was his dryer. And so we did a span there. Didn't have to, but we also specified a 20 amp heat pump, right? So we, one of the reasons we love Mitsubishi is because we can specify smaller breaker sizes for their systems applications. So we wanted Mitsubishi for him and a 120 volt heat pump water heater. Okay, last one, or I might have one more. In Berkeley, 125 amp service. Had a few breaker slots left, but to kind of achieve his full electrification plan, we needed a little bit more space and capacity. So we ended up doing a circuit splitter between the water heater and the 20 amp heat pump. Again, specified a 20 amp instead of a 25, 30, 50 amp heat pump. In this case, we were enabled to do that. I mean, you know, we did a load count for the house to make sure we were meeting the right size for the house. But we shopped around, we kind of looked for the system that would allow for the lowest breaker size.
When I've noticed a couple of them here, you do some sealing and then you do the heat pump.
Yeah.
How much does the sealing impact the amperage? Can you say go in, it's like I started at 50 and I've sealed, like incrementally, it's
Yeah.
like, so like, if you think of it like a cost basis, like a step.
Yeah, usually we're talking about maybe 5 amps, 5 to 10, but it makes a difference.
5 to 10 for a whole house seal.
Yeah, for a whole house.
Okay.
But that makes a big difference, right? Especially if it's gonna flag an $8,000 panel upgrade.
Yeah.
Let's just do a little insulation and air sealing for a smaller system outside that's gonna run lower, you know, amperage, run more consistently, keep things even in comfort. Yeah, so
So,
that should be its own standalone slide is insulation and air sealing.
so 5 to 10 amps saving on a whole house seal, which is,
But that's also 100% coincident because it's on the HVAC system, so it makes a big impact.
how much, the whole house seal, how much?
So, I don't know, it all depends on the house and load calculation, right?
Right, right.
And how far we're going with air sealing, right? Because, you know, they might have decent condition insulation up in the attic, for example. It might not make sense for us to take it all out, seal everything, put it back. So maybe we just hit the ceiling from under the house. But generally what we find from like kind of lightweight air sealing and then recent attic insulation is that, you know, roughly 5 to 10 amp difference in sizing system.
Is that something you guys do as well, the ceiling piece or?
Yeah.
Contracted?
Oh, yeah, anyone can do it. Sometimes we try to get our homeowners to do it, because they'll do a way better job than us, you know, trying to rush through a house and get it.
Nobody wants to
Find a hole, squirt the foam in it.
Under the
That's
house.
it.
Yeah.
Do you have
Yeah.
data for your air sealing of like lower doors or anything like that, or?
Some, yeah, I mean, we should be doing it on every house, but
You have to use
extra time and logistics.
like a big house,
Times money, they want to add the additional.
And they just
Yeah.
say, so.
You know, like when I got started with the building performance stuff, right? A ton of blower doors, Larry did the same thing, he was actually the contractor at the time. After doing it enough times, you get a good sense of where you need to seal, but, that's not an excuse for not testing, it's still a good idea to test. So, anyways, okay, one bonus example, 100 amp Zinsco, you want an EV charger and full electrification. So this is what a Zinsco looks like. And we put in a new 100 amp panel, so we increased the capacity, but we upgraded the panel. And we put in a simple switch between the range and the EV charger. And then again, Mitsubishi heat pump, 240 volt heat pump water heater, and all of this. So anyways, that's all I got.
Very cool.
Thanks for spending lunch with me. Any other questions or things we didn't get to?
When you're going through these homes, I mean, how are you thinking about putting like storage, like integrating, are you building, like, because you have to have your controller and are you building in panel space and like, are you installing the panels and everything such a great, you just pop the battery here and then you're easily running it, or are you like, we'll cross that bridge when we get to this house might not even need it, or is that part of like the menu of options?
Yeah, we probably don't put as much thought into it as we should, honestly. Our focus is kind of appliance electrification. But yeah, it maybe depends on the customer's journey as well, right? We walk into, it's increasing, but maybe 5% of homes already have batteries there. Maybe 50% of the homes that we touch, we have a slightly different clientele, but 50 to 70% already have solar.
Yeah.
Right. So the conversation is a little easier in those cases. But yeah, I wouldn't say it's rigidly on our planning process for every project. And sometimes we do say, let's leave the panel upgrade to the solar and battery guy when you're ready for that, but you're gonna need to be prepared to do that when the time comes, and here's a rough cost for what that looks like.
One comment and one question. One of the things that pushed the panel upgrade for me was the limitation on solar generation
Oh,
based
yeah.
on panel
Yeah.
size. So you didn't, I don't know if you want to speak to that at all. But I do have one question. My only gas appliance left that is dragging, I have not gotten an electric dryer yet. So I just don't know if you have any thoughts on heat pump electric dryers. I was having trouble like procuring one. So I just decided, so I'm thinking I might just get like a used electric resistance dryer to tide me over for a few years, but I didn't know if you have any leads.
Depends on your lifestyle, how quickly you want your clothes dried, how many loads you do. The heat pump dryers are notorious for being difficult to clean. So hopefully they made some improvements on that, but over time, kind of the insides kind of get kicked up and you gotta sort of take it apart. If you want to do a really good cleaning job to get the capacities running at max.
What do they do on the discharge, the cold air?
For the,
Discharging the cold air, you're making it hot, you gotta get rid of cold, so does it mean it has to be on an outside wall with a?
No, it runs in a circle. It condenses the water out.
Oh, it does?
yeah,
Oh,
that's
okay.
just all.
It's like evaporator and then a condenser, like in
Okay.
series.
Yeah. All in one. So no hole.
Okay,
No venting.
that's cool.
So
Okay.
if it was me and my lifestyle, I would probably put in a resistant one if the panel could take it.
Well, there's no panel limitation now.
Yeah, exactly.
And I already have the circuit. Circuit's there.
But again, that's just me and my lifestyle.
Yeah.
And maybe keep an eye on the heat pump dryers over time. And if you do buy this one, maybe you won't feel as guilty for swapping it out for a heat pump dryer, maybe after you figure out how to whatnot.
Yeah, yeah. No, we do. The laundry all piles up and then we try and get through it all in a day. Yeah.
The cycles are much long.
Thanks.
Looks like we have a question from the Zoom audience.
Oh, yeah, go for it, Zumi. Armando.
Hi, can you guys hear online, folks? Hi,
Yeah.
Alex. How's it going?
Hey,
Good to see you.
What's up, buddy?
I'm wondering about the span electric panels. I mean, those are really nice, shiny, new looking technology, really exciting, expensive, as you mentioned. How how are you guys going about configuring those, prioritizing circuits and all that? And is it kind of like a set and forget process for the homeowners, or are you seeing them engage and wanting to kind of interact with that technology? Like, what's the level of engagement slash kind of engagement on your end versus the customer end on that front?
Yeah, very good question. So yes, well, first of all, we've only installed, I don't know, 5 or so of them, so not a huge
Yep.
data set. Yes, it's usually set it and forget it, based on an initial conversation with the customer. And the folks, it all depends on the customer, right? Like some people geek out on all this stuff. Some of them are like me and you, and they're in the middle of the energy industry, and they want to do, maximize load shifting, like they know the lingo, right? And others,
Yep.
like, you told me I should get this panel because it's gonna help me in the future, so, whatever. Like, they're not gonna look at the data or anything, but it's still a good solution for them. So.
Yep.
I think it really all depends. And then in terms of which circuits we're prioritizing, I've only set up one myself, but on that one, the first thing that I triggered to shed was the dryer, because it's pretty low impact.
Yep.
High amperage device to shed if it's triggering it to be on. And then, just based on a conversation with the homeowner, we prioritize all the circuits after that. So yeah, the neat part is that it is very intuitive, very easy to set up, their app. We've had a couple issues connecting it to Wi-Fi and all the stuff you would.
Yeah.
Something smart, takes way longer to set up, but the outcome has been good so far. It's delivered on what's promised.
Great. Thanks, Alex.
Does, the span panel doesn't allow you to hardwire it? Like with Ethernet or like, you have to use Wi-Fi, I guess.
No, you can hardwire.
I can
hardwire
hardwire
it just
it,
about once.
Right, yeah, okay.
You prefer the hardwire, but very often it's just that possible.
Yeah, I think the connecting the Wi-Fi bit I was referring to is connecting from my phone.
Okay, yeah.
For installer stuff.
And then the span, can you dynamically reprioritize loads? Example, in the summer during a extreme heat events, whatever, AC is, the last to go, or something like that, right? Is it, are you able to do that, or?
Yeah, you essentially just say, well, it depends on what you mean by dynamic.
Meaning,
Like, you could go in during the hot season and change your preferences.
Yeah.
If that's what you're getting at.
they have to go in and say, slide a button, but it won't be like, here's different, prioritization schedules based on certain scenarios, and this is like the trigger if temperature is blah for X, or like something like that.
Yeah, I don't know. It's a smart device, so if not
Presumably, yes.
currently, then at some point, maybe there's like an if this, then that type of setup.
Should know what the temperature is, right?
Well, I wouldn't say like, necessarily it needs to know, I mean, your house is gonna have a thermostat, but like, my thinking is not like, I'm gonna tie into, maybe this doesn't necessarily need to do this, but like the KISO, new grid emergency, right? So when there's a weather event, right? It'll take that in and then like say, okay, great, this is gonna be a problem.
Yeah.
So between hours of 4 and 9, or whenever you set it, right? We're turning off everything, and then we're going to cycle the AC, cycle the AC. You're not controlling like the actual like unit itself, but you're just saying we're gonna like, I don't know, I think of it as like, when you're driving a car, sometimes you pump gas and coast. So it's just like you pump it, pump it.
I love the concept, and if it's not something they've already done, it should probably be something they're thinking about.
I know someone there.
Sorry,
Yeah.
You work in smut territory?
Not too much, but we will go to Sacramento.
Okay, because one of the issues they have now is the heat pumps where they give a rebate, they're not the heat pumps where you get a federal rebate.
Well, yeah. That's a whole other box to
Yes.
unweave, but,
And that's
Yeah,
because,
we can chat about that one.
I think it's just by they're going to the rating system. I think SMUD's still going by AHRI, the federal tax rebate's going by, Energy Star, most efficient.
Yes.
Yeah, yeah. With the manufacturing, we dealt with that when we came out with new products, so.
So, yeah, I feel you're
Yeah,
paying.
I think the federal ratings haven't really caught up yet, and just the way systems are rated is maybe slightly antiquated. Right, but for a variable capacity heat pump, that's gonna be running hard load. That's not what the rating is based off. The rating is based on 100% capacity under the same instances as single stage heat pump.
Well, that was their argument too, a certain heat pump from a certain manufacturer is only at 100% data efficient, but if it goes at 50%, it's totally different.
So hopefully that'll be just over time.
The federal standards actually do take into account the part load condition for variable speed heat pumps.
Oh, really?
Yeah,
Under-
but it's not like continuously variable, so it's
Right.
kind of like a discretized, depending on which climate.
No,
Not
that's year
zone,
round.
but they have
That's year
a
round.
bunch of
Year's
different
the season.
climate
Yeah.
conditions.
Yeah,
So depending on where it ends up, but they did a pretty, with the limitations of how it has already been set up, they did a pretty, in my opinion, a pretty good job, trying to get it to fit. And
Okay,
treating
yeah.
it as variable, but.
yeah, I stand corrected. I'm going off of a presentation I heard a couple months ago.
Okay.
Yeah, I think it's certainly something we continue to fine tune and improve upon based on, realized system performance, and that getting back channeled into the ratings is important as well. Yeah. Any others? Anyone else online?
Yeah,
Okay, another one.
for the, heat pump water heater. In some houses, there's like a nice little closet you can put it in some houses not, and it's like, do you take effort to, or is there, when you have a nice little closet, do you re-insulate that to keep it cool longer, keep it hot, or whatever it is, right? So you can,
Yes.
you do.
Short answer, yes.
Okay.
And yeah, nice little closet is our enemy when it comes to heat pump water heaters. They are very differently sized than a gas
Yeah, yeah,
water
yeah,
heater. And the installation of a heat pump water in a closet is extremely challenging. We luckily have an option now of one that has ductwork inlet and outlet on the top, so you can duct the cool air out at least, which was a bit of a problem in the past. But yeah, always a good idea to insulate the closet. Now, if it's in the middle of the house and, it's part of the envelope,
Yeah.
maybe that's slightly different, right? So the insulation in that case might be for some sound deadening.
Yeah.
But, it's not gonna really help with the thermal properties if you
Okay.
duct in and out the airflow.
Does, you use all tanks, right? Tankless.
Only tanks. There isn't really an electric tankless
It was
scenario that fits well for a whole house.
But the reason I asked is, I know I've met Tom several, I used to work for Princeton Energy, and Tom works with them on a lot of their building electrification stuff. One of their building electrification program managers is Blake Shaft or something. And-
Like H.
Yeah, Blake H. You've probably, yeah. He, and when I was there was a lot of work with, trying to do a 120 heat pump water heater, and you can have tank versus tankless, and there was, it's called, they're doing a pilot with a company for a 120. And I thought it was tank, now completely forgetting some of the questions that's. Let's there, let me look it up.
All good. What's the what's the intended outcome of what you were bringing up? Was it with respect to, easier
No, it
applications
was-
for a
it-
closet or for?
The intended question was, given a capacity size of a panel and a home size, is there any benefit one way or another from recommending tanked or tankless, which doesn't exist? That was the intent of it, as like a, given a portfolio of loads that you have, like a tanked works really well, like it works very well together in this combination, kind of like Tom's, his thing
Yeah.
versus like this, and maybe you want like,
Yeah, if there's space, we'll put it in. If not, then we have to make some careful decisions. So there's, if the closet's wide enough, right, there's a whole bunch of stuff to think about, right? There's like airflow, there's the physical size, not just the physical size of the unit, but plumbing that goes on the side sometimes. Can we actually get our hands in it? Wait a minute, we have to service these things at some point.
yeah.
How do we get to the screw in the back? Like, right, what else? Yeah. Noise is a giant one, right? Anytime we're talking about closets in a house, it's just, usually becomes an issue. So we could put in a Sanco 2 split water heater that makes no noise inside, but is that gonna fit in the closet? And then it's gonna cost twice as much for the customer, but it might be the right solution. There are some manufacturers out there that have systems that you can adapt to an existing tank. So that might be a potential solution. Keep the tank that's already in that narrow closet and pipe a heat pump to it, but those are kind of early in their ratings. They don't get rebates.
I was confused. So the pilot's called, it's with a company called Harvest Thermal.
Yeah.
And I was confusing it with, it wasn't a tankless, it was, they were putting the compressor
Yeah, so
outside for.
they've got, they've got the same code, it's the same system I just brought up. That's
Okay.
kind of split and makes no noise inside.
Yeah.
But you need a real big tank, at least 83 gallons long, at least 19 gallons, which is, like, it's really big.
Yeah.
It takes up a lot of.
If I'm right,
space.
isn't Sanco strictly doing it for heating purposes? They're not going for domestic water.
In that circumstance,
Yeah.
for harvest, it'll provide both.
Okay.
But you need their special control system to be able to have the brains to
To do both,
make that work. So it's really cool.
It's a
But-
subscription.
But you need some space for
service.
this.
Which, it's a, subscribe to your heat pump with
At
our.
some point, yeah, you have to put a coin in.
Yeah.
There are some, like on-demand heat pump water heaters,
Yeah.
but from my understanding, they're generally for low temperature water, for like hand washing, that kind of
Yeah. As opposed to.
Yeah, I'm really I'm excited to see what they do with the battery integrated ones and any different form factors. Like, something we come across in the Bay Area where space is a premium, and people have converted their houses with, over time to get the water heater outside. So they put the tankless on the side of their house and there's 3 feet from property line. We can't put a tank there. So what do we do how are we gonna electrify that house?
Put it in the ground, bury it.
Sometimes we put it back in the basement where we took it out of to begin with, but that's not always an option. So I don't know, maybe if there were rectangular tanks you could put on the side of the house or something.
Yeah.
You're gonna figure that out for the next project.
I'm mechanical, I don't wanna deal with the trying to hang, 83 gallons off the side of a building, like, that's big.
Get a big old auger, drill a hole, drop your tank down below. That way it's thermal to the ground.
Yeah.
Good insulation.
Yeah.
Put a manhole
Yeah.
over it and service it.
Yeah, I don't know, or horizontal tanks that can go into the house.
Yeah.
But then you don't get stratification.
very
Rooftop is common in other countries.
Yeah.
Want to call them and look at it.
They got tiny tanks, because they use a lot of water.
Well, not just that, but I had a professor from Iran, and they have passive heating, so they just, because it gets hot over there, so they just have a tank of water with a pipe, and just from natural convection.
Yeah.
It'll chilling
Yeah.
through, yeah.
That's cool.
How deep do you need to drop a underground? Is it cylindrical or are you dropping like a pancake, tank? Like if you're burying it underground, because there's probably limited on depth, right?
I'm sure you would be.
I don't know. I'm gonna leave that question to the engineers.
They should dig a hole. You gotta get below the frost line.
Yeah. Yeah.
Yeah.
All right. Well, it was fun chatting with you guys about panels.
Thank you.
And nice to meet all of you. This is So, hi, and bye to anyone who's left online.